Okay, fine. So let me clarify the problem you are facing in this particular circuitry design. First one is whenever I use some of the circuitries to like demonstrate the simulation, we always utilize the coin 3-volt battery like this one or the 1.5-volt battery. Okay. So, but
Okay.
in here, in this particular circuit, there is one problem. You must take care of the total voltage is required for the circuitry to work as well as the power source you are using. In my last class, I mentioned one of the regulators, right? That was the 7805 regulator. So what we need to do, we have to convert the 9-volt power coming from the battery to 5-volt and degrade it to the step down it to the 5-volt so that our circuit will work perfectly. So I'm placing one of the 5-volt regulator, that is 7805 regulator, transistor based regulator. So in regulator, what we do have input, ground, and output. Okay. So what I will do, I will take one of the wire and connect the input section. Input is this pin to the positive wire and change the color accordingly. Color code is important, orientation is important. Otherwise, you will find difficulties when you go for the actual PCB designing in your future projects. And I will let you know in one more series of classes the reason why we gathered in here today to explore the possibility of programming from the today onward only. And further, we will have a brief sessions on different circuitry building. I will help you to design PCB as well in my classroom program. So I connected the negative wire, the ground pin to the negative of the battery. So right now what we need to do in here is to disconnect the power source you were providing to the these things. So I'm just making one of the common in here so that it will be helpful for me to like connect each and every wire. So this wire is common now. This wire is in here common, and again changing this particular wire from this place to this place. So now everything connected in common, and the negative will be connected directly to the power source. There is no issue on that. But this particular wire, the positive one, needed to connect it on the out of transistor. So the time when I will hit this simulation and click on any of the button, there is problem is still. Okay, there is problem is still. Let's find out what is the problem happening in here. So
Saurabh I'm very sorry to interrupt
yeah,
here, but I have a very basic question. I
yes,
remember,
sorry,
I think I was muted. Okay.
yes, ma'am.
The thing is, whenever we use the push button,
Mhm.
I remember we were told to use the opposite, legs of
Diagonal pins, right?
diagonal of the
Yeah,
push button. But I see here that the one of the the two parallel sides are getting connected out here. Is this how it should
yeah,
be done? Correct me
yeah.
if I'm wrong.
Yes, you are absolutely correct on that point. But the problem is when you will have the physical push button in your hand, you cannot able to locate which one is the parallel sides. So that is the reason I asked you to connect always in the diagonal mean so that it won't be confusing to you. Okay. The reason why I asked you to connect it on the diagonal basis because it won't be confusing for you to connect the push button in your circuitry all the times. You will find no problems at all each and every time you will connect those to the circuitry. I hope
I think I understood it only very vaguely. Probably you can proceed. I will catch it up a little
okay.
later.
I will let you. I will explain the internal circuitry how this push button is oriented, and I will try my best to explain why I asked you to connect it diagonally rather than the parallelly. Okay. So right now, what we do have problem in here is the resistance. Let's change to the 100 kilo ohm. Start the simulation. Okay, even though the 5-volt is much higher for the application, so I'm changing the value.
Okay. Another question now that you are working with the resistor, is
Yeah.
that, I was trying my hands on, trying to come up with some kind of a circuitry as a trial basis. And
Yes,
most of the
ma'am.
time when I did the simulation, it started bursting. The bursting symbol came up. So I realized that probably the volt that was going into the bulb was more, and
Mhm.
that is why it is bursting. Okay,
Yeah.
now, you have to really do it only on a trial basis to find out how much of resistance must be used, or is there a
No, no,
way
no,
to
no,
find it
no.
out?
The concept which I taught earlier, the V is equal to IR, you should utilize that concept to like find out the resistance required to run this particular device. So basically, the V required, the all overall V we are getting from the regulator is 5, right? So we are getting the 5 volt in total, and what we need to do, we have to check the current requirements in this LED. For this particular LED, the current required is 0.30 milliampere. So you must calculate the R according to the need. What we do have to find out through this segment. Like through that, you can able to find out the resistance value, exact resistance value. I will explain
So
you with one of the PDF in which I will try my best to explain how to calculate the resistance for each and every individual electronic components. Okay, I will help you with that after this class.
yeah, okay, thank you.
Okay. So now I change the value back to 330 because the 330 ohm is suitable for this particular application. And thank you, Nirmala ma'am, for turning your camera on. And maybe that is happened by mistake. So no worries. Thank you so much, by the way.
You,
So
sir, for
yeah,
helping out.
yes, ma'am, please.
Thank you, sir. Now
Okay.
it's coming
So
right
now it is
because
perfect, right? So you
yes,
must
yes.
convert the voltage to the smaller values. Then
Yes.
only the circuitry will work properly. Otherwise, you will get that explosion symbol on top
Mhm.
of the LED. You must take care of the voltage and current requirement. And yes, to clarify the doubts, what is the exact resistance is required for individual components, I will share one detailed PDF for each and every LEDs and other electronic components which we are using in our circuitry development in Tinker CAD platform. Okay, I will help you with that. There is no issue on that. So for me, it is experimental as well as I do have a proper experience doing the trick and tweaks in this circuitry. That is why I always come up with the exact value what is required, because I do know that 330 ohms, 220 ohms, 100 ohms is the standard value which we can get from the market, and I also utilize those in my circuitry development. So yes, after having a proper experience, you will also come up to the same position. But for now, I will help you to how to calculate the exact resistance required in this circuitry itself. So I believe, Vageshwari ma'am, your doubt is clear in this circuit,
Sir,
and
yes, sir.
other team members, please help me with your doubt as well, so that first 20 minutes or 30 minutes will invest on the doubt clearing stuff. Then we'll move back to the main chapter today, which I'm going to explain the Arduino and its application, as well as we will start the basic Scratch programming to make our LED work. And further, I will introduce you the embedded C, because we plan to go with the as per the ICSE and CBSE syllabus, ICSE syllabus especially. But what happened? I was like invested so much of my time explaining the core concept. That is essential also, but we will move back again to the main syllabus from the board members. Then only this classroom program will be helpful for you to conduct these STEM classes in your school. Otherwise, it is all about the Tinker CAD and all the simulation stuff we went through, right? So I will add those chapters and try to provide another 10 days session for you all to have the brief understanding of the syllabus, and I will provide the notes accordingly as I promised earlier in the group itself. So I'm moving back to the design section, and help me if any other member do have any problems in the circuitry. Like they submitted already plentiful of circuits in here, and I'm so happy to see them.
So I just made one. I don't think if it's correct. So I think it must be under my thing. Circuit, logic circuit or something I've written.
Okay, Nirmala ma'am, your design is not visible in this section. So have you submitted this in this section, or you designed it
No,
somewhere like
sir,
in your
somewhere
group?
here only. I think one of this in this section only. I think student work. I remember.
Okay, the first one or the second activity? In the
I
first
think
activity,
the first activity, sir, it's that just the basic thing which you said. I used to,
okay,
okay, I used just the two battery and used a resistor and LED, I think so. Just that basic circuit, that's all.
okay. In here, in the first section, I find the designs for
First circuit, not this
Lakshmi
one.
ma'am, Lakshmi Subramaniam ma'am, and Bhagyashree ma'am. Both of them submitted in
No.
the first, and in second,
Mm,
Lakshmi ma'am, Chaitali Hingnekar, Bhagyashree ma'am, again Bhagyashree ma'am. So yeah, I'm so
no.
happy to see the contribution of Bhagyashree ma'am. She done a really great stuff in here. So in the third,
Mine is not there.
no ma'am,
Mine,
Chaitali Hingekar, no
I don't
ma'am.
know where I put, sir. It was
Okay, maybe.
something basic. It was something basic, but I don't see my LED glow there.
Okay,
Something
may you please
similar
help
to
me?
this one, sir. This one only, the one which you had done as simple as that. But I don't understand why did you turn the battery, sir?
Okay, may you help me
Because we could,
with the components you used in the circuitry so that I can align those stuff
yes,
and
sir. I will
make the
tell you
relevant.
how. Yes,
So I'm
sir.
dragging and dropping the
Yeah,
breadboard in here. So help me with the other components. What
yeah.
you use? The LED,
First,
right?
I used, yeah, LED, fine.
Okay.
Then I used a battery.
Which
Okay,
one? The
one
3 volt
battery,
or
nine.
1.5 volt?
Nine, I think, nine.
Okay,
What is it?
9 volt
Yeah, nine.
battery. I'm
Yeah,
connecting the
one
9 volt
here.
battery in here.
Yeah, and one on the top.
Okay, the resistor.
Yeah, resistor. Okay, I used two batteries. So there's another battery on the top, sir.
Okay, two batteries, 9 volt battery, right?
Yes, sir. Then
Okay,
the positive of that was connected to the negative of the second one, of the
okay.
first one.
The positive is connected to the negative of second one. Now
Yes.
connected. Yes.
Yes. And then the negative of the second one was connected to, I also used a switch, sir.
Okay, this light switch.
Yes, sir, correct.
Okay,
Okay.
this light switch.
So
Yes.
I connected the negative to the extreme right.
Okay, the terminal two, right?
I think so. Okay. Then the
Okay,
other one left, I connected to the resistor.
the other one you connected to the middle one.
Yeah, not the middle one. I connected the first one.
Okay, the terminal one to the
To
register,
the
right?
resistor. From the
Okay,
resistor, I connected to, where did I connect? Now I'm getting confused, sir.
the LED, the LED
Ah,
itself.
yeah, LED.
Okay,
But LED has 2 points, right? Yeah,
yeah.
one was connected to the negative of that. I think so.
It won't be connected to the negative, but
No,
rather
I
than the
have,
positive
yeah,
one.
positive. Yeah, it will be connected to positive. The other one, the circuit to be
Okay.
complete.
So
Okay, yeah.
now in this
Mm.
situation, this circuit won't work because as I mentioned earlier, this particular slide switch does have the three terminals. So
Yes, sir.
whenever the slide switch on the left hand side means terminal one and common pin are joined together now. So the time when we shift this switch to the right hand side, then
Mm.
common and terminal two will be interconnected. So this won't work properly. And also you will find one more difficulties in this circuitry because the batteries are connected in series, then yes, this battery is supplying more than the enough required voltage. If I connect the
Oh.
voltmeter to test out the voltage in between, suppose if I'm connecting one of the wire like the negative one in here, and
Mm.
I will take another a wire of red color, connect this battery in here. So if I hit this simulation, you will find there is
Mm.
relevance of
18.
18 volt in total, right? So
Mm.
this is not going to help you because you are utilizing the battery more than the required capacity. So try
Okay.
to use the batteries according to the need. If you are going for this series or parallel connection, then there is another type of batteries as well present in this Tinker CAD platform. You can utilize the 0.3 volt battery or 1.5 volt battery.
Oh.
Then only it
So
will
the
help.
power was more here.
Yeah, sorry, ma'am.
There was more power here. Power supply was more
Yeah, the
in the
supplied
battery.
voltage and amperage is more than the required ones because we are only utilizing one of the LED to like we
LED.
have only one of the LED to power up, right? So if we are
Yes, sir.
putting the batteries in the series combination, then we know in series it will become double of it, right? Because two battery are similar in power. So 9 volt plus 9 volt, it will become 18 volt in total. So there is no requirement to have the 18 volts in total in here. It will only burn your electronic components, nothing else. So in place of this 9 volt battery, if we place the 1.5 volt battery, then this particular circuit will work perfectly. There will be no issue on that thing.
Okay.
So if I rotate the battery,
how did you rotate, sir? You use this one to rotate.
This
that
tool is
triangle
there, right?
Yes.
This tool is there. The time when you click on the battery and click on the rotate tool, then it will rotate the battery. And now you can see the terminals are not properly aligned. The positive is on negative side and negative is on positive side. So what I will do, I will click on the battery, and after, just next to the rotate, we do have mirror component option. So just click on the mirror component option, then your polarity will be reversed. It will change its
why did you turn 1 minute, sir? Why did you turn it, sir? You could have kept it as is, and positive could have been connected.
Always have to use the standardized values, standardized everything in your circuitry. Then only it will be helpful for to take these STEM classes. Otherwise, it will be confusing for the students to like connect. So in breadboard, we do have power section both in the upside and bottom side, right? So you can see the numbers, the actually the symbols for positive and negative are engraved in the breadboard. So you must connect the battery according to the engravings. Otherwise, it will create a huge confusion. And also utilize the same color code for the power section. So whenever you will use positive, so try to use the red wires, and whenever you go for the negative, then utilize the black wire. And apart from the positive negative, suppose if you are connecting the switch in between or doing anything, then you can choose any of the color of your choice, any color of your choice.
Okay, so my battery was wrong.
Yeah, the battery was wrong. If I now start the simulation, then you can see there is 3 volt only. So we don't have to do anything. We just change the value of resistance in the circuitry. So let me change.
Saurabh, I have a quick question on this particular circuit. Can you just blow this a little more?
Yeah.
Look, I just have a question regarding the LED bulb connection there. You earlier said that the longer leg is the anode and the shorter one is the cathode.
Yeah.
And therefore it should go into the negative. Am I right? But then here I see
the connection is wrong because we did not completed the circuitry. So I have to rotate the object now. The anode is on the positive node and negative is on the cathode side.
But is it how it should be? Should the resistors one end not be with the anode and the negative of that should be connected to the negative here?
So there is no issue whether you connect the resistor into the negative terminal or the positive terminal. The positive terminal, like the anode in here, is connected directly to this wire, and it is connected now with the battery terminal, right? And negative terminal is connected to the one of the terminal 2 of resistor, and then second terminal 1 is connected to the terminal 1 of switch, and middle common pin of the switch itself is connected to the negative of the circuitry. So if I hit the simulation, then yes, this circuitry will work, but we need to change the resistance. So let me drag the resistance in here. Let me change the value to 100 ohm, and I will place the resistor back into the place. So if I hit the simulation, then this circuit will work perfectly. So the time when I'm turning on the circuitry, so it is withdrawing 0.01 voltage from the battery combination, this series combination of battery. Otherwise, it remains 3 volt if it is turned off. Okay.
Yeah.
So make sure
change the resistance to resistor. It's resistor 10 to 100.
Yeah. Sorry, ma'am. May you please repeat that for me?
Yeah. I mean the capacity of the resistor was changed to 100. No, sir.
Yeah. I changed the value to 100 because there is no such higher voltage. Only 3 volt is in here. So I'm reducing that actual amount, like 1 volt. The LED in here works in 2 volt perfectly. So we have to reduce 1 volt in between. So I utilize 100 ohms only. Otherwise, if I remove the resistor from the equation, if I stop the simulation and remove the resistor and connect this particular wire directly to the pin of LED, then let's see what happens. So if I'm turning on the switch, so again, the current flowing through the circuitry is more than the requirements. So the LED works perfectly in 2 volt, approximately 1.5 to 2 volts. But at 2 volts, it will show you the high brightness. At 1.5 volt, it will run normally. Not much, not less, but it will run properly.
Saurabh ji, a question out here.
Yes,
How will
ma'am.
I know what should be the power that should be supplied to an LED?
Okay. I mentioned earlier as well that I will send you one PDF to with the data sheet. Whenever you buy some of the components from the market, let me show you one thing. If I search one of the thing, LED power supply or LED power requirement, so the Google itself will show you how much voltage is required, 1.8 to 3.3 volt, depending on what type of LED you are utilizing in your circuitry development. That is the main idea behind utilizing each and every component. See, I do have one of the LEDs with me, that is the green color LED, and this particular LED works well with 1.5 volt to 2 volt, not more than that. So we do have another kind of LEDs like the bigger ones, which utilizes 3 volt in total or 5 volt in total. So there are varieties of it. So whenever you buy components from the market, make sure that you are the technical specification of that component. You should get the technical specification of that component. Even though the time when we are going to utilize the Arduino, then there is also different variety of boards present in the market. So if I go through the Arduino UNO, then it requires the operating volt is 5 volt. The input voltage, which is recommended, which I mentioned earlier as well, 7 to 12 volt, and limit voltage is 6 to 20 volt. That means you can able to supply 6 to 20 volts to the board itself, but the recommended voltage from the manufacturer is 7 volt to 12 volt. So you should go through the specification of the device you're going to utilize in your classroom program. Otherwise, what will happen? It will cause you the damage. So here there are many questions. Can I use 12 volt 2 ampere for Arduino? Yes, you can utilize 2 ampere of power source, but it will overheat the board. So regulator is not designed to handle that much of amperage. So I recommend to go with the 12 volt 1 ampere so that it will work perfectly for longer period of time. So this will come to you after having proper experience. If you spend some time in utilizing these kind of devices, then you will find yourself in a place where you will understand how to choose the components and what are the power requirement for the components itself. So I hope the doubt is clear from
Yes, sir. Thank you, sir. You can continue with the class.
Yeah. So I'm again moving back to the section to create new circuitry, because today we are going to do the experiment with the Arduino board itself. So I'm just naming this thing up Arduino development. So before moving directly to this particular section, I would like to explain something like I always do in my classroom program. First, I will help you understand the basic aspects of Arduino boards, like the development boards. Then further, I will help you to go with the programming, because it is essential for us, ma'am and sir, to have the core knowledge than only to have the Arduino, programming. Like you will find plentiful of videos in YouTube as well, but that is not the accurate version of how we can start the programming of this development board and proceed with the same. So I will help you with that. So let me share one thing with you before moving to the programming section. So I hope my screen is visible to each and everyone.
Yes.
Yeah. So
Yes, sir.
this is the basic Arduino board, right? The Arduino UNO board, which I showed earlier as well in my classroom program. So one of the board I do have in my hand is the Arduino Nano, right? You can utilize any of the development boards to learn the programming, because Arduino Nano comes under very low cost. So you can buy these as well. Otherwise, I will prefer you to start with Arduino UNO, because it is good in size, as well as it does have more capacities like the memories and the processing speed and many aspects. It is far better than the Arduino Nano. The smaller the board you will use for the programming and project development, it will have a less memory compared to the bigger ones. Like the Arduino Mega does have more capacity than the Arduino UNO. So you have to choose according to your need of the project itself. So the Arduino UNO is the standard one, and everyone starts their journey with the Arduino UNO, and you should also go with the Arduino UNO. But as a professional, I will suggest, if you would like to invest less amount on that, then start with the Arduino Nano. It is also similar to the Arduino UNO platform. So now you can see there are plentiful. If you already bought this controller from the market, then I believe you already seen how this thing is works, right? You already went through, maybe you already went through the Google search and all, and YouTube videos to understand the basic aspects of Arduino. So how many of you purchased the Arduino, you know?
Sorry, not me.
Sir, I purchased, but I don't know. I can just
Okay, there is no
Sir,
issue on that,
we
ma'am.
purchase it from Google, sir.
Yeah,
Where do we purchase it from Google?
there is
From
plentiful of.
online? Online?
Yeah, if you can able to find it in your local store, then go for it. Otherwise, if you go for the online, they will send you the replica of Arduino, rather than the actual board, and it won't last longer than the required time. So try to buy the
Okay.
genuine Arduino. It will cost a little bit higher in price, but
Mm,
it will stay longer for a longer period of time with you. Okay, yes,
okay.
Bhagyasri ma'am and Kirti sir.
I purchased it, but I not prefer the online because you told us to better to go to purchase it from
Yes.
the vendor. So one of my friend helped me out in this too.
Yeah, that's
They-
great, ma'am. That's great. Really great of you.
Because sir, we don't have any idea ki online mein how.
Okay, send me the photograph of the purchased. Okay, then I will let you know what are the
Right now,
variety.
I will just send you right now on the
Okay,
group.
send me a personal message directly to my WhatsApp
Okay,
number, so that I will help you further with that. Okay.
okay.
And Kirti's Nayak sir, please. You also raised your hand. Sir, I purchased the Arduino online. Yeah, there is no issue on that. But I asked you to go for the genuine Arduino, because the longer you want to use this device, because I do have one of the Arduino, from 2014, I'm utilizing the same with me. So there is no issue on that with the original Arduino, and it is working perfectly like a butter. So you should go with the original Arduino, rather than the replicas of, because there are many varieties from the Chinese market which offer you to in less price, but it won't stay for a longer period of time with you. Okay, so let's start this journey with the Arduino, Yes, Kirti sir. Yes. So let me use the annotate tool in here so that I can able to explain you the basic aspect. So in the board itself, you will find this section in here. So first one is the reshade, second one is the 3.3 volt pin, third one is the 5V, and fourth one is the GND, fifth one is the GND, and again V in pin. So whenever you see two of the terms mentioned in the board, like the V in and VCC, it stands for positive 5 volt. Sorry, the positive voltage. Okay, V in and VCC stands for positive voltage. VCC stands for positive 5 volt, and V in stands for 7 to 12 volt. So it is the range between 7 to 12 volt, the V in pin. You can utilize these pins to supply the power to your board, as well as you can utilize the power from the board in case if you are attaching some of the sensors and the output devices. And apart from the V in and GND, VCC, we do have another pin, that is the GND pin. So GND is nothing but the full form of GND is ground, and it stands for the negative voltage. The negative voltage Yeah, sir, I'm not Kirti, sir. Myself, Mrs. Kirti Naik. Okay, sorry, extremely sorry. Kirti ma'am, sorry, extremely sorry. So yes, so moving back to this section. So whenever you see G and D, it means the negative, because I never heard your voice, Kirti ma'am. That is why I was like confused, like to whether to call Mr. or Mrs. So extremely sorry for that. So negative voltage, GND represents the negative voltage in the circuitry, and VCC stands positive 5 volt, and VIN represents 7 to 12 volt. Or these two together represents the positive voltage in the circuitry. So make sure you are connecting the proper positive and negatives to the desired output and input devices from this power section. This whole section is known as power section, and I will leave this reset, the first pin, the reset pin for now, because I will explain that in a later video or the later classes. So then only it won't be a confusing for you to understand the thing. So this section is known as power section, and just below the power section, what we do have is the analog input section. So I already explained you the digital and the analog things, like what is analog and what is digital. If I again explain you in a summary, analog versus digital. Analog means it is the range between 0 to 1, means either the value will be 0 or 0 0.1 or 0 0.2 or 0 0.3 up to 1.0. So it is the range between 0 to 1, and in digital system we follow two values only, 0 and 1. Either it will be off condition or on condition accordingly. So here we do have a pins, set of pins A0 to A5 dedicated only for the analog inputs, and you know well where we will get the analog inputs. If you do have any doubts, then please help me with your doubts, then I will explain why we need to have the analog inputs in the board itself. So I believe I explained that in my sensors chapter of sensors, where we do have different kind of sensors like temperature, humidity, and so many other devices. And those particular sensors does requires the analog input for the microcontroller. So that is why we do have dedicated analog input section in this Arduino board. So apart from this, what we do have is this right hand side. We can see there are pin, namely 0 to 13. This one is known as the IO pins. And why we do have IO pins? Yes, to provide the input and also to get the input, as well as to provide the output to the output device, or like the motors. So input device is my sensors, and output device is our actuation system or locomotion system. Actuation is all about, let me give you one example so that it will be easier for you to understand. The motor, LED, the buzzer is all output device, and in sensors the input device is all about the IR sensor, PIR sensor, and humidity sensor, temperature sensor, and so many input devices we do have for the same. So we can connect the input things or the output things directly to the pin number 0 to 13. Okay, pin number 0 to 13. And make sure you should not use the pin 0 to pin 13 to like connect the two devices on same pin, like input device and output device on the same pin. Otherwise it will create a contradiction between the both of the input and output system. So make sure not to connect two of the device in single pin. Whenever you are utilizing, suppose if you are utilizing pin 13 for any of the input device, then do not use this pin for another purposes, or for any output device. Make sure to use these pin only for one purpose, either input or output. Okay, so apart from this, you will find one of the symbols on some of the letters, like pin 3, pin 3, pin 5, pin 6, pin 10, sorry, pin 10, pin 11 does have one of the simple symbol in front of it, like the AC symbol we all usually see in our electronic appliances in our home, right? So this symbol actually represents the PWM, and PWM is nothing but pulse pulse width modulation. PWM stands for pulse width modulation. So suppose if we do have dedicated inputs for the analog things, then we must have some of the pins to generate the analog output for the same. So to generate analog output, we do have dedicated pin for that. So either we can utilize these pins with this symbol to generate analog outputs or any digital outputs. So we cannot able to generate the analog outputs in other pins except these pins, the PWM pins. So always remember, whenever you have to control the speed of motor, like if you have to increase or decrease the speed of motor, for an example, I'm just giving you one example to understand, then you should utilize these PWM pins for the same. So this is how I can explain you the Arduino UNO. And let me tell you one more little more about the Arduino UNO. Apart from these pins, you can find two of the LED on board that named as TX and RX. So TX stands for the transmission protocol and RX stands for the receiving protocol. So whenever we will try to communicate with this device, then what we will have, the TX and RX LED will glow simultaneously whenever it is communicating with our computer system. And apart from these two LEDs, we'll find another LED in here that is written as L, and this particular LED is directly connected to pin number 13. Means this particular LED is known as inbuilt LED, and we will find relevant function in our programming environment as well, like the Arduino IDE, or even though the Tinker CAD platform does have the same. So whenever you will do the programming for pin number 13, then yes, this LED will reflect directly, like it will also reflect the value of the things you are doing in pin number 13, because it is internally connected with the pin number 13. So apart from this development board, what we do have is this IC in between, right? So this is what we call the microcontroller. This IC is known as the microcontroller. So this whole device is not the microcontroller, but I often call this device as development board only. This one is the development board, and the IC is the microcontroller. So this microcontroller does have the capacity to rewrite the values, and it is one of the kind of IC which is known as EEPROMs. EEPROMs stands for electronically erasable programmable memories. So this particular chipset in here is known as the microcontroller, and this whole board, the combination of different electronic components, is known as development board. The development board manufactured by Arduino, and the specific model is UNO. You will find the relevant component mounted, soldered in the board, like the Arduino Nano and Mega does have the same kind of components in the, but more than the Arduino UNO. Okay, so apart from this, what we do have is the power jack in here, and as I showed you through the Google search, power jack is responsible to handle the voltage between 7 to 12 volt. That is the recommended voltage to like drive this complete development board. You should not exceed with that limit, and you should always use 1 ampere adapter for the same. Otherwise, there is a more adapter available in the market, like the 2 ampere or 3 ampere. You should not go with that. Otherwise, you will burn out your board. So what we do have in here is the development board, which runs on the 1 ampere of current. And as I already mentioned, remember, ma'am and sir, I already mentioned one of the things, that microcontroller only requires 5 volt of potential to run, right? Then if we are supplying 7 volt to 12 volt, then how it is operating under 5 volt condition, right? That will be the major question to ask. So in here, what we do have this particular device, and this one is 7805 regulator, which I showed you in the Tinker CAD platform as well. So this transistor does have 3 pins. One is the input, second one is the common, and third one is the output. So 7805 regulator takes the 7 volt to 12 volt input and provides the 5 volt output to the microcontroller to run. So our microcontroller, either we are utilizing any of the IC, it will run on mostly on two of the voltage, that is 5 volt and second one is 3.3 volt. But in this case, this microcontroller is running on 5 volt. And if I ask you a question like how is it possible for us to keep track of the time? Anyone would like to answer? How we can able to keep track of the times?
You have the CMOS battery, right?
Suppose as a normal human being, if I ask you to how you will keep the timings, like
Watch.
using the watch, right? You do have watch, we all do have watch or some kind of stuff to monitor the progress of time. Then how a microcontroller will come to know that this particular time is required for the execution? So we do have one of the thing in here, like this silvery thing in here, and it is known as, okay, let me remove the drawings, otherwise let me take the screenshot first so that I will help you with the photos in the group. Then I will remove the drawings, and each and everything which I mentioned is clear to you, to all of you, right, ma'am? Answers?
Now that you
Yes.
asked, I have a question here.
Yeah,
Earlier,
please
you
help me
had
with the question.
mentioned that there is something called as an analog input section. Am I right?
Yeah,
Which is on the left side bottom. The
yeah,
6 pins which are used as analog input pins. Okay,
yeah.
now when on the right hand side, when you mentioned it, it was called as the
IO
0
pins.
to IO
Yeah,
pins, right?
yeah.
So when you already have an analog input pin mentioned as 0 to 6, what is the
Mhm.
necessity to have another set of input pins? If it makes for an output pin, it makes sense. But why do you again want to have an input there?
Yeah, the reason why the Arduino UNO does have that much of pin, because we can connect many devices, many sensors or output devices as possible. The analog section is dedicated in here to integrate the analog thing only, analog inputs only, but we do have IO pins to operate the same for the output section. So we can able to produce the output using these pins, the PWM symbols on it. But yes, you can utilize both of the pins for the analog input and the PWM pins for the analog input as well as the analog output. But yes, we do have separate section for the analog input. That is only because they design it to do the work in there.
So if I have to give a digital input, how will I be able to? Which pin should be connected to?
Digital input will be connected to any of the pins 0 to 13.
So ideally, just correct me if I am wrong. I will use pins A0 to A5 if I want to give analog input, and I can use any pin between 0 to
0 to
13 if I
13.
want to give digital input,
Yes.
and take an analog output also.
Yeah.
Am I right in my understanding?
Analog output only on the PWM pins, the symbol on front of the pins.
These things that is located in between 0 and 13.
Yeah. Yes, ma'am.
Right, but then when I want to use a digital input, I will use pin 0 to 13.
Yeah, for digital
Right?
input and digital output, you should utilize the 0 to 13 pins.
Fair enough. Thank you.
Including this PWM sign, those pins
including
also.
the PWM sign.
Okay.
Always remember that PWM is only for analog outputs, as well as the other input and outputs for the digital system. But that analog output will only work on PWM pins.
Okay, sir, got it.
Okay. So apart from these, analog inputs can also able to handle the digital inputs. There is no issue on that because I tested some of the program by providing the digital inputs to this pin. But we do have dedicated section for analog pins in here, because you will find two more things written in here, SDA and SCL, which I will explain in my future classes. Apart from the pin number, you will find plentiful of information is written in here, right? So each and every pin does have specific roles to provide. That is why we do have separate sections for analog input as well as IO. The IO for each and every component. Ma'am, you are audible.
Tasmita, ma'am.
Ma'am,
You're
you are
audible.
audible. So yes.
Oh, sorry.
Okay, no worries, no worries. So now, if I move back to the yes. So if I go back to the concept, yes. So here what we do have one of the silvery device, and this is what we call it as crystal oscillator. And crystal oscillator is responsible to provide the time sense to the microcontroller. Usually 16 megahertz crystal oscillator is used in the Arduino, but more than that is utilized in other board as well. So 16 megahertz is the ideal one for Arduino UNO. This particular crystal oscillator is responsible to provide the time sense to the board itself. Okay. And what we do have apart from this crystal oscillator is this button. You will find some of the reset button in this location as well in your duplicate Arduino UNO. So most of the Arduino UNO does have the reset button in this particular place. And the reason why we do have reset button, because if our program is not running abnormal, like it is not behaving, the microcontroller is not behaving properly, or if you'd like to start the program from the line 1, then we should hit this reset button to like reboot the entire microcontroller, and the microcontroller will start reading the instruction from line 1, and it will reset itself. Each and every value and each and every stored data will be reset, and it will start initializing the thing from the beginning, from the line 1 itself. That is why we do have reset button. Apart from this reset button, what we do have one of the connector, the USB connector of A type, and along with the Arduino, you will find A to B type USB cable. A to B type USB cable. B is the USB 2.0 for the computer connection USB cable, and A is this port. You will see this particular port means this is the A type of connector. So the microcontroller does require a proper communication with our computer to get it programmed, right? So to make this thing happen, so we do have one bridge IC in here. The bridge IC is responsible to stabilize the communication from the computer, and it will interact directly with the microcontroller in here. So that chip is responsible for the communication. We call it as the bridge IC. So this particular IC is responsible for the communication between computer and our microcontroller IC, the microcontroller IC in here. So this is all about the Arduino, apart from these pins like 0 to 13 and power section and analog input, we do have another pair of pin in here. So this is what we call the programmer pin or ICSP pin. I will explain those ICSP feature and other things in the advanced classroom program. So after this 10 days session, we will have another kind of session to help you understand the advanced versions of Arduino platform, as well as other major microcontrollers. So I believe now the concept is clear for the Arduino UNO board, and you will find two of the capacitors in here. The capacitor, if I go deep into this Arduino UNO explanation, so capacitor is used, as I already mentioned in my earlier classes, to store the energy, as well as it will reduce the fluctuation of energy or voltage or current in between the circuitry. So capacitor is used for that purpose only. And apart from the capacitor, we do have one more device in here. So this particular device is known as comparators. Comparator. So what will happen, why we do have comparator in here? Suppose you connected the power source in here using the adapter, okay? And also supplied the power to these particular pins, the V in to positive 12 volt and G and D, you supplied negative voltage, okay? So you connected two of the power source to the Arduino board. Then what this comparator will do, it will compare both of the voltage, and it will choose the best voltage or best power input from the source. Then it will direct that power to the microcontroller. That is only for the comparison between two of the voltage coming from the V in and GND section. Otherwise, the second option is there using the adapter jack, the power adapter jack in here. So if we connect two of the power source in the board at the same time, then the comparator will compare the voltage in between, and the best voltage will be chosen to supply directly to the microcontroller. That is why we do have comparator on board. So
Saurabh just a quick
yes,
question before you move forward. You had mentioned that there are two types of jacks there, the type A and the type B, right?
yes, ma'am.
Right. One is the type B is used to connect the USB cable. What is the
Yes.
purpose of type A?
Okay, the type A. Okay, fine. Let me
Okay,
clear the
and
ground.
a supplement question to that is that of late you will find the computers, the laptops having only type C connection.
No, many of the computer does have the USB 2.0 in it.
But it is being, it is becoming slowly obsolete. They are insisting only on a type C connection.
Type C is something we do find in our mobile phone as well, right? That particular
Right.
type.
Yeah. So type C of late, you get it compulsorily in all the phone models, but slowly the laptops are also moving only into the type C model. So if
Yeah.
you have a type C model kind of system, how would you use this?
Then you have to get one of the data cables for A to C connectors. You have to get the data cable only from the market, A to C type.
Okay.
This particular port is known as type A port.
Okay, what is the
This
purpose of the type A port?
the type A is only used for different microcontrollers, or we can say that the low end devices or low programming devices. Type A connector will be there. So we do have different kind of connectors in the computers. So even though the floppy drive does have different connector, the SSD or hard drive does have different connectors. The SATA connectors, SSD and hard drive does have, right?
Yes.
The SATA connectors. The SATA, and now apart from the SATA, there are other connectors used for the SSD. Earlier, it was the SATA connectors were used for the hard disk, but now for SSD and all, the SATA connectors were removed and directly 3.0 USB 3.0, or we can call it as the C connector, is employed in this segment. Even though if you utilize any of the external hard drive in your computer, then you will find many of the external hard drive does have the same USB 2.0 or the C connectors in between. So there are varieties of connector we do utilize in the computer system, but for the sake of like technological advancement, yes, this thing will be replaced in future. Many of the Arduino boards and the ESP board especially, the ESP always come with the micro USB ports are there in the ESP models like Node MCU and other microcontrollers. Even though some of the advanced version like Arduino 4.0 does have the C connectors in it. So you will find plentiful of different connectors in between. Only you have to get a specific type of data cable to connect the hardware to your computer system. If your computer does have the C connector, then yes, you should go for the A to C type of data cable to connect that thing in your computer.
Okay.
So A is this port. This port we know it as the A type of port. And yes, apart from this, any serial data cable will work in your computer. So now the doubt is clear. So shall we move forward?
Yes, thank you.
Yes. So even though we do have the reset button, but one of the pin in here in the power section does have the reset value on it. So what happens when we try to take one of the wire from the reset, and if we take one other wire from the ground and try to sort this wire for one tile, if we touch using the push button in between, if we place one of the push button in between, then it will also work as reset button for the microcontroller, because microcontroller is always placed inside the case, and the structure is not visible from the outside, because we only take out the wires to connect each and every peripheral devices like the sensors and all sorry, sensor and output devices. So to accommodate another reset button, we do have this particular reset pin over here. So all we need to do, we have to take the wire from the reset pin and another wire from the GND pin, and if we have to place a push button in between, so that it will work perfectly to reset the microcontroller to the original state. Okay, so this is how we can able to summarize the Arduino UNO in total. And also there are many other aspects as well in this segment, but for now it is enough for you to like start with the programming environment. So if you do have any doubts, then please help me with your doubts. Otherwise, I will move forward with the programming part. Anyone do have any doubts? No. So let me share my second screen, which is the Tinker CAD. So I believe my screen is visible to all of you. So
Yes,
now,
sir.
so here, as I explained earlier, we do have another different things in here. So let me change the name first. Arduino first example. Okay, so that it will be helpful for us to remember which program was first and which program was second. So I will go back to the component section and I will choose the Arduino in here. The time when you will click on the Arduino, you will always find the pre-built examples to explore in this segment. So we won't start with the pre-built samples. We'll just move back to the all component segments and just scroll down a little bit to find the microcontroller section in here. And in here, you will have the different kind of microcontrollers. Even though you can utilize the Arduino UNO for the application, otherwise we do have ATtiny in here, microbit and microbit without with breakout. So we don't need to use the microbit for now because we are focusing only on Arduino. So you can utilize the Arduino UNO board in your experiments. Otherwise, also, you can also utilize ATtiny. ATtiny is the smaller variant of this microcontroller. So this is also manufactured by the Atmega. And in here, the microcontroller we are utilizing in here, the microcontroller is manufactured by Atmel, and the model number you will find in your written in your board itself is Atmega 328, and the suffix will be P, PU, or U. These three variants we do have in the microcontroller. So this is the basic version of microcontroller we will find in the Arduino UNO board. So ATtiny does have the same feature, but it does have less pin compared to this Atmega 328P 328P controller. So we won't utilize ATtiny for now. So we will only focus on the Arduino board. So already I explained you the term, and you can see the digital and PWM pin are mentioned clearly in this chapter. Apart from this PWM pin, we do have 0 and 1, that is the TX and RX pin responsible for the transmission and receiving. So either we can able to communicate with the microcontroller using these pins, which we will do the experiment in our future classes. So I will explain each and every aspect from the starting point so that it won't be a confusing moment for you to understand this board development board. So after dragging this thing, so let me bring two more components that will be our LED, because we will do first experiment with the LED, and also we need to have one of the register along with the LED. You know why? Anyone do have idea why I'm going to use the register in between, not the LED?
Because
Oh,
the
burst
LED will require
does.
less voltage, right? So this
Mm.
will be using 7 to 12,
Yes,
but you will require lesser there.
perfect, ma'am. Remember one of the concept I taught earlier. Let me go back to the Jamboard. One of the concept I taught earlier. Suppose if we are talking about the digital system, then okay, if I'm talking about the digital system, then in digital system we do have the two values, 0 and 1s, right? So 0 represents the off condition and 1 represents the on condition, right? If we talk about the appliances in our home, electronic appliances in our home, then off conditions means we are supplying 0 volt to the device, and on condition means 220 volt to 230 volt we are supplying to our devices in our home, right? For Arduino, or any other microcontroller, we do have to deal with 5 volt in total, the maximum of 5 volt. So the condition 0 and 1 will be for microcontroller, 0 for again 0 volt, and 1 will be for 5 volt in total output. So these pin in here, like 0 to 13, will generate the 5 volt in total whenever we will go with the high mode. Or we can say that if we supply the on condition with any of the pin, then it will provide the 5 volt in total. So we must reduce the voltage to the desired one. So we will utilize resistance in between to not let our component, like the electronic component, burn out from the extra power. So I'm connecting one of the cathode. Cathode is the negative terminal. So I'm connecting the cathode directly to the ground of Arduino and going to utilize the another wire, red one, for the terminal 1 to the pin number 13. So now the LED is properly connected to the Arduino board. So it's time to go for the programming. So we will click on the code section and let's remove these pre-built codes in here. So I will go back to we do have different blocks in here. So first we will start with the blocks, then further we will proceed with the block and text to see what is the changes is happening along with the blocks arrangement. And also we will finalize this thing with the text editor, that is embedded C++ programming. So I will go back to the control section. In here, you will find each and every control and the conditions, the statements.
Sir,
like
1 minute. How
yeah,
did you get this part of the screen, sir? This one?
you have to click on code map. You have to click on code.
Code.
Yeah. The time when you click on the code, it will show you what is the coding environment, the programming environment.
Okay, sir.
Okay, so in controls, you will find the basic control and different loops. I believe you already aware of the loop system. Loop is all about suppose if you're trying to repeat one of the things in the programming, then we should utilize the forever loop, right? The forever loop is for the complete to repeat the things again and again. So I will just drag and drop the forever loop from this segment in here to the programming environment. Right hand side, we do have programming environment. So I just brought the forever loop. And right now, one of the devices connected is the output. So we will focus only on the output block. And here you will find the output, different things related to the output to control each and every things in connected to the Arduino UNO. So we do have two of the basic options to start with. First one is the set built-in LED to high, and second one is the set pin something to high. So let me show you, both are the things are same if you are utilizing pin 13. As I mentioned earlier, that I mentioned one thing earlier, this particular LED in the board itself is directly connected with the pin number 13. So that is the default value in the Arduino programming, default thing in the Arduino programming, that it does have set built-in LED or set built-in pin. So whenever we talk about built-in LED pin, that means we are talking about pin number 13. So either we can able to utilize the first one or the second one for the same programming. Let me show you what is the basic similarities between both of the things. So I'm just dragging and dropping this set pin first, so that I can able to show you the correct sequence on that. So I will change the value of pin to the desired pin, like the pin 13 we are utilizing for this programming, and I'm changing the value, like leaving the value high in total, like low is for 0 and high is for 1. So high will create 5 volt of output and low will create 0 volt of output. So if we hit this simulation, then what will happen? Let's see. So if we hit the simulation, the LED will start glowing, but on continuous node, right? So if we stop the simulation and drag this thing and dump this thing in the trash, if we again drag the first block, that is set built-in LED to high, then this particular thing will also work the same, because set built-in LED is the same function which calls the pin number 13 to do the programming on that particular pin. So either we can utilize the set pin and change the pin in here for 0 to 13, and also we can utilize the set built-in LED for our application. So now what we need to do, we have to stop the LED, because we are going for the first program, that is the LED blink program, for you to understand the concept of programming. So we'll go back to the control and drag and drop the wait symbol. Okay, so it will help us to hold the current state of LED, like we are sending the high signal to our LED, and it will hold that signal for 1 second in total. Then I will again go back to the output and again drag and drop, set built-in LED to high, and go back to the control, again bring back the wait one in below of the forever loop. So I will change the second value of set built-in LED to low. Then only in first instance, what we are saying to our LED, go for the high mode, then wait for 1 second, and again go back to the low mode and wait for 1 second. And these
So
things
it will keep blinking.
yeah, this one is the blink program which we are experimenting, and through this waiting time it will hold for 1 second and complete. It will run on continuous mode because we mounted it on forever loop. So forever loop will help this thing to go back again and again executing the same command from beginning. So if I hit the simulation button, then what will happen? Let's see. So it will be on for 1 second, then it will turn itself off for another 1 second, and it will go on a continuous note until unless we hit the stop simulation button in here. So this will work indefinitely. So if I drag and drop this function from in here and remove the set built-in function and go to back to the output and set pin, I will drag and drop the set pin and bring the wait block, then again arranging the things with the wait block. Then I'm changing the value of pin to pin number 13, and in here also we'll change the value to pin number 13 and changing the value to low. Then also it will work the same because the pin 13 is directly connected to built-in LED, and that is the default feature in the Arduino environment. So either we can choose this type of block, otherwise the set built-in LED will always call the pin 13 for the execution. Okay, so to further move in this program, let's bring another LED into the picture, change the color back to the green, and I'm going to drag and drop another resistor and change the value of resistance to 220 ohm or 100 ohm of your choice. So the 220 ohm will work perfectly, and I'm taking one of the wire, the black wire, to connect it directly to the ground because we always connect the ground section in common. So I'm dragging and dropping it to the ground, and now we're left with another wire. So I will take the red wire and connect the terminal of your choice. Let me know which pin we will connect this LED. Which pin you want me to connect this LED, please?
Anything should be fine. Say 2.
Okay, fine. So I'm connecting this thing to the pin number 2. And now what we need to do, let's go back to the code and hit the simulation. Then this LED won't work until and unless we will bring the blocks for the application. So I will again bring back this set pin just below to the first pin, and again on in here as well because we want to run it on a loop. So I will change back the value of pin number to 2. The second pin will be 2, and I will do the low on first and high on second. So what will happen? Let's see. If I hit the simulation, then one LED will on, the second LED will turn off itself for
Flip
first.
flop.
Yeah. So what we just created, we are operating two of the LEDs using the same forever loop. Otherwise, you can also bring any of the controls to control this LED in the programming environment as well. So this is how we can able to go with the basic code block-based programming in the Tinker CAD environment, as well as if you do have the physical Arduino UNO with you, then you just have to click on the code and change the value, stop the simulation, change the value to text, and you will find the exact C++ programming for the same response for this particular programming. I will explain you this thing in details because if not explained in details, then it will be complicated for you to understand and execute the advanced code in the programming environment. So for now, practice the thing based on the block level programming. Then I will further introduce the embedded C programming for you to understand the concept in proper note. Okay. So apart from this, what I want to show you today, okay, Kirti ma'am said pin
Sure.
number 12. Pin number 12. Okay, no worries. Let me bring back another LED and change the color to the orange, or we can say the blue. Okay, and I will bring another register in between and change the value to 220 ohm. And then I will take another black wire and connect the cathode of LED to the ground section, to the ground pin, and the
So,
positive of, yes ma'am.
the way you are able to connect all the cathode to the ground pin,
Yeah.
I'm not, because once I connect the red one, I'm not able to connect the green one wire to the ground pin. I
Okay, is
tried.
it possible to share your screen and show me
Yeah,
where
yes, sir.
you are
This is
studying? Okay,
PR.
let me execute this program first, then I will
Yeah.
help you with that.
Okay,
Okay.
sir. Yeah.
Okay, I'm moving back to this section and dragging and dropping another thing. Okay. So set pin too high. So I'm changing. You can able to rearrange the things. There will be no issue on that. So first pin was my second, and second we chose the 12. So this one will be the second, and this one will be the 12. So let me change the value to low, and second pin will be high, and 12 will be low. So if I hit this simulation, so you can do the experiment according to the LEDs. You do have many ports. You can utilize many ports as possible for the same. So let me give you the capability to share your screen, ma'am. May you speak once so that I can find the exact profile for you?
Yes, sir. I could do it. I could.
PR. Okay. The
Yes, sir.
PR.
I could do it. I understood my mistake.
Okay. You understood the mistake?
Yeah. No
Okay.
problem now.
Okay.
Thank
Fine,
you.
ma'am. Great. So let me show you another examples, which is what I'm going to cover in my classroom program. Then only it will be interesting to join over this classroom program. Otherwise, we already I already explained you the terms related to the theoretical portion, but be assured that that theoretical portion was totally required for all of you. Otherwise, I won't cover anything irrelevant to the topic. Okay, because we are going to become the proper STEM educator in our occupation, and there is no place for the people who will just use the basic programming language and they do not have any code language knowledge in this session as well. So let me share my screen with the programming which I would like to showcase in my next classroom program, because we do have limited time for this classroom now. Okay, so I'm sharing my screen with the pie chart. Okay, I believe my screen is visible to all of you.
Okay, just before you get into this kind of a coding, I have a
Okay.
question. Is
Yes, ma'am.
Tinkercad the only platform that we can use to do this, or offline? So this is online. Tinkercad is online. So is there any other offline application that can be
Yes. We do
used?
have plenty full of softwares to utilize it on the online mode. So I will help you with the name and all in the WhatsApp group itself. So there is no issue on that. I will help you with that. So Tinkercad is best because it does have each and everything in here. So apart from the Tinkercad, we do have plenty full of softwares, but you have to buy those softwares to like go for the experimentation. Otherwise, there is no
Oh,
specific
there is
way to
no
do
such
it.
thing, though, no freewares out there, is it?
Freebies, no. There is no specific freebies out there.
For the children to learn. So
Yeah, only the
okay. CAD is like
platform
that.
is the free one.
Okay, fine.
So even though if you would like to have some of the software for the simulation, I can provide you that. But yes, you have to buy the license from the manufacturer of those softwares.
Okay.
And there
Sir,
will
one
be,
more thing.
yeah, yes, ma'am, please.
Sir, can you show the code for this, what is right now, the 3 LED thing that you have put up? Yeah,
Okay.
I just want to take a screenshot of this. I can try it later.
And also I will
Yeah.
share the recording of this session, ma'am. So
Yes,
there
sir.
is
Yeah.
nothing to worry about.
Yeah. Thank you, sir.
And this particular example will be there in your class section. So you don't have to worry about this thing as well. You can able to tweak my design as well. You can able to copy it and use it for your own purposes. There is no issue on that.
Yes, sir. Thank you.
Okay, because we do have limited time for this classroom program, I believe today is our we are going to have 2 more classes for the same, because I promised for the 10 classes. So I will try to provide another type of 10 days session for the advanced programming and relevant to the programming as well as the Python programming. Then only it will be good for you to have the outcome of these sessions, right? So earlier I shared one of the program, the Python program itself, which I made for the student to have the understanding of visual processing. So I'm turning off my camera in here to showcase exact mean what I'm trying to explain in my last classes, which I missed to explain. So if I hit the run button in here, then what will happen? I'm going to utilize my camera in this program. So just allow me a second, please. So now the program is running, and if I share my window, okay. So if I share my window, you can see if I bring any of the components in here, like the mobile device or the phone case, it will keep track of those components, right? The devices itself. So if I bring my mobile phone, then yes, it will also detect the same. So I will introduce these programming features in my upcoming classroom program. And if you see the outcome of this programming in here, you will find the persons along with the mobile phone is detected in the programming environment. So I will explain those in my future classes. I will start a series of lecture on programming, specifically on programming, not in this STEM, but to help you understand the scope of this whole journey. So I believe each and every doubt is cleared for now. So if you do have any doubts and anything relevant, then ma'am and sir, please help me with your question so that I can conclude this today's journey.
So we go to Tinker CAD and we can do all that what you've done today, right, sir?
Yes, absolutely. You can go back to the Tinker CAD. Let me show you how to do that. If you move back to the Tinker CAD platform, and the time when you will go inside the activities, here we do have Arduino development. Just click on it. You will find my example as well. And in here in the below segment, I will find your work. So you will find mine work as well in this. So you just have to click on Tinker this. You will be landed on this particular page to see the codes what I used in this session, as well as the relevant connection for the each and every LED and register for the same.
So let's do that once more. You go to Tinker CAD.
Okay, just go back to the Tinker CAD, and under the activities, here you will find your classes. Under the activities, I created one activity today on September 9, 2023. Click on the Android development and you will find the circuitry made by me, and also the circuitry of other, like Mrs. Kriti Nayak ma'am also done one of the circuitry. So you will find each and every circuitry made for this in this classroom program.
Yes, sir. Thank you, sir.
And also I will share the screenshots of those Arduino written things, Arduino or UNO board, for you to understand and keep that as a note for your future reference. Okay. In the group itself. After this meeting, I will share those in the group itself.
Saurabhji,
Yes, ma'am.
can I ask now?
Yes, ma'am. Sure.
Right. You had mentioned some of the parts to be, some of the units to be used for this particular, working in the group itself, isn't it? Is it like, you can get us those components from somewhere, or we have to do all the digging and getting?
As ma'am, I already said that this one is the free classroom program, then that is why it is not possible for, yes, I can get that from market because that is nearby to me. But yes, it will take more time to like get product and courier it back to you. So yes, ping me back separately. I will help you to
What
resolve
is
this
likely
issue.
to be the cost of all those units put together? Any idea? Rough idea?
I can summarize the complete cost from this
Sure,
shopkeeper
you can
itself.
message me, DM me on my
Yeah,
WhatsApp.
just ping me over
sure.
WhatsApp. I will revert to you back. Okay.
Yeah, certainly I'll do that. And
Yes.
regarding these advanced coding classes, will this be a continuation of these free classes that you're doing, or do we have to join the course and then only we will be able to get that?
It will be like the sequential of these upcoming classes. After
Okay,
these
so after
10
these
classes,
10 classes, right?
I
Okay.
will try my best to provide and support you on that. I've never asked for anything for the classes. I won't ask for. If I need,
No, I just wanted to know for a
some point of time,
clarification.
yeah, in some point of time, if I need something from your side as well, then I will love to ask for help. If I need
Certain.
only.
Thank
Okay?
you.
Yeah. Okay, I'm stopping the recording for
One thing
now.
I want to ask.
Yes, ma'am, please.
This is related to that LMS thing. So we got